Hi. In this tutorial, we are going to talk about how we can determine the number of protons if we are given the mass of an element. Um, just like in this question. We have 60 grams of calcium and we are asked to find out how many protons are there. So before we do anything on the board or on the paper, let's think about, let's build some conceptual thinking. Okay, let's have some concepts of what it is. So if we have 60 grams of calcium, so maybe like this size, okay, or even smaller, then there are many calcium atoms. And in each calcium atom, we have 20 protons. So we would like to see how many protons in total are there in 60 grams of calcium. So let's think about this. So we would like to find out the number of protons. Okay, and how are we going to find this number? Okay, now if we have one calcium atom, then we know there are 20 protons total. Okay, that means if we know the number of calcium atoms, then we're good. So what we are going to do is to first, well, we gotta know how many calcium atoms are there. Now, can we find out how many calcium atoms are there? Of course, because if we know the mass, there should be a way for us to find out the number of calcium atoms. Well, here we don't have a really direct connection, but what we can do is to, let's say, find out the number of moles of calcium atoms. Okay? And how are we going to find out the number of moles of calcium atoms? Well, you have the mass right there. And if you look at the periodic table, you have the molar mass of calcium, which is around 40. Okay? So by the use of molar mass, we are going to be able to find out the number of moles of calcium, and then we are able to find out the number of calcium atoms, the actual number, and then we will be able to figure out how many protons are there. So we start off with the mass of calcium atoms, which is the given. Okay? So we have 60 grams of calcium. Okay? And we can refer to the periodic table to find out the molar mass of calcium. And we would find out that there are 40 grams of calcium in 1 mole of calcium. Okay, make sure the conversion factor provides a valid statement. It must be in a valid relationship. Okay, now before I write the next conversion factor, I would like you to understand that if I stop the calculation right here, what are we finding out right here? So if I stop right here, what we're going to get is the number of moles of calcium atoms. So if I stop right here, I do the calculation, I should be able to find out the number of moles of calcium atoms. And then we carry on our calculations. So we got the moles of calcium atoms. We would like to find out the actual number of calcium atoms. So we will use the Avogadro's number. Okay? And we should be able to do that to calculate the actual number. And at this point, we have the number of calcium atoms. And now, at the very end, how are we going to find out the number of protons? So you have to think about a ratio. Okay, this is what it is. It's a ratio. And it is a ratio here in between the calcium atom and the number of protons. So we understood that in every single calcium atom, we have 20 protons. And that is going to be our ratio. So we use that statement and to create our ratio. So one calcium atom would have 20 protons. One calcium atom would have 20 protons. Okay? And we can simply carry out the calculation, and let me step aside and do the calculation. So after the calculation, we have the answer. So there are a total of 1.8 times 10 to the 25 this amount of protons in 60 grams of calcium. So by this calculation, I would like you to understand how we're going to process the information, how are we going to think through the hoops, okay? The hoops to go from the mass of the calcium atom all the way to the number of protons. Make sure that for every single conversion factor, they must be based on some valid statement. Every single ratio must be valid. Check before you write it down. After you write it down, check again. Okay, and that's going to help you out big time to be successful in this type of calculations.